Hello. Let us start about how to optimize a software performance and how to become a software globally scalable. Today, I'll be giving about an overview with our limited time for the key strategies and techniques for optimizing software performance and effectively scaling it to meet the growing demands. In our day-to-day life, we'll be using all of these categories. Every common man in this world will be using these categories of software such as e-commerce, mobility, social media, streaming, and communication. Well, that means Amazon, we are using daily basis. It is having 200 million users out of 8 billion users over the world. Google Maps, 1 million billion people are using it. Facebook, almost 3 billion people are using on daily basis. That means half of the world, almost half of the world. And Netflix, WhatsApp too. Without these softwares, there is no daily life nowadays. These softwares are not privileged or they do not have freedom to stay idle for even a single second or even a single minute. That will impact badly the software industry. How does this software become so scalable and it's highly performing without even a second delay? Let us see some core strategies that can be adopted for improving software performance and scalability. If we come about software performance and its optimization, we need to think multiple factors in mind. One is improved user experience, as the users will not be only the techies, it will be used by common man also. We need to have the best user experience, including the user interface, how to use it. We need to optimize it to enhance the experience by providing faster response times and smoother interactions for more engaging application. And the next one will be increased system scalability. That means anyone has to be able to access it the same speed from South America or North America or from India to America. It should not be depend upon the geography. It should be accessible to everyone. Efficient resource utilization. So if we are considering both scalability and user experience, resources will be spiked. That means we will have to enable multiple resources in the background with multiple systems, with high CPU systems, high memory systems, and top bandwidth. The cost also will be shooting. For making the minimum resource utilization, we need to have multiple strategies to be adopted to make it efficient, which will end up in reduced operating cost. Investing in performance optimization is a crucial step towards building a scalable and efficient system that delivers a superior user experience and maximize the organization return on investment. There are multiple performance optimization techniques. Let us see one by one. One, will start from code optimization. Next, resource management. Next, architectural design. Next, we will come to profiling and monitoring. We have algorithm optimization also and database optimization also. Code optimization will come with programming languages mainly. We will be having multiple programming languages to develop different softwares. Whatever programming languages it will be, we have to keep optimize performance optimization in mind and have to come up with the coding standards and templates which need to be aligned across the development of the software. Techniques such as minimizing memory usage with per programming language, reducing computational complexity, leveraging the language-specific optimizations will improve it while developing the code itself. And the same way, efficient allocation and utilization of system resources like CPU, memory, network bandwidth will maximize the performance and it will avoid the bottlenecks. I will come to bottleneck analysis part later in this video. While designing architecture, we need to keep performance in mind. For scalability, for front end, for back end, and for the middleware systems, for the network bandwidth, all the things should be keeping in mind for architectural design. We will come more about in this video. Designing software system with scalability, modularity, and performance in mind, including the use of caching, load balancing, and microservices architecture. If we come to profiling and monitoring, it will come the next step when we are ending up in a performance issue. We need to identify why does it happen. For that purpose, we need to keep profiling and identifying the root cause for that. Monitoring enables continuous monitoring of the system for a specific period of time to identify where the system is failing at any moment of time. Employing tools and techniques to identify the performance bottlenecks, measure and analyze system metrics, and continuously monitoring application will improve performance optimization. If we are using algorithm and data structures in our software development, selecting and implementing the most efficient algorithm, which need to be documented, drafted, and proceeded as per that, will improve the performance optimization by leveraging techniques like memorization and parallelization. If we come to the backend side, database side, server optimization, along with optimizing database queries, schema design, indexing strategies, need to be identified, listed, and need to be proceeded to further optimization of data intensive application. This will be really important for the big data world, which will be coming now, and also in artificial intelligence and machine learning based applications. We talk about performance optimization now, and that will cover the responsiveness and throughput, latency, etc., which I will again cover in coming slides. Let us talk about scaling. We need to get our software accessible across all geographies in the world, means we need to adopt proper scaling strategies. There are multiple scaling strategies called vertical scaling, horizontal scaling, cloud-based solutions, load balancing and clustering, caching, asynchronous processing, and microservices architecture-based architecture. If we come to vertical scaling, is a traditional approach. Nowadays, it is not recommendable. It will be having only single system data center, we will be increasing the CPU memory continuously in that one, so that the system will grow according to the demands, which is not recommendable for a geographical based scaling strategies. Horizontal scaling, that is, if one machine fails, then the entire program will fail. If we are going for horizontal scaling, we'll be having multiple nodes, multiple systems. If one node fails, also the other nodes will continue working. The application will be more resilient and more efficient, and it will be more stable, distributing the workload across multiple servers to handle the increased traffic. So recommended way for scaling is horizontal scaling. Next comes to cloud-based solutions. So on-premise data center will be the one which will be using for most of the legacy systems in current world. Now everyone are taking their steps to move towards the cloud-based solutions like Azure Cloud, AWS, Google Cloud, and many other software companies has their own cloud implemented. So all these cloud-based solutions are giving cost-optimized way of utilizing the hardware and infrastructure. Therefore, pay for whatever we use is the concept in cloud-based solution. We don't want to pay for the entire data center and the on-premise servers. Instead, we just need to pay on what we are using. Out of cloud-based solutions, one of the latest strategy which we can adopt is to use multi-cloud infrastructure also. So we can efficiently use our own cloud systems for developing activities, and we can use the cloud-based paid services for expanding our business globally and proper scalability. The next step comes for load balancing and clustering, distributing the incoming traffic across multiple servers to optimize resource utilization. If we are having some 10 servers, load balancing will help to map the incoming traffic to as per 10 servers properly. But whether they are separated servers, no, they are not separated. They will be clubbed as a single entity using clustering. Next, if we come to caching, there are multiple caching types which I will come in coming slides. Caching is the most accessible data, most accessed, frequently accessed data should be available in a high-speed storage for the users. Implementing in-memory caching, it will reduce a lot of database and server load. So in traditional system architecture, the synchronous processing was implemented. The asynchronous processing method, which will offload the time-consuming tasks to background processes to improve response time. It will not wait for all other requests to complete to start the next process, that they will complete it parallelly. All the processes will be implemented parallelly using the CPU resources available, so that no request will wait, and it will be really helpful. Asynchronous processing is one of the strategies to be implemented for having the most scalable and high-performing system. In traditional architecture, we'll be having client-server architecture. The entire program will be developed as a single architecture and will be delivered. In the current world, or current frequent changing world, that is not a recommended criteria for architecture design. We need to go with microservices architecture. Microservices architecture will decompose the entire application into smaller independent services to enable smaller and flexible scaling criteria. Even if one component fails, still the application will work in the other area. For example, in an e-commerce website, logging into the application and searching for the products, checkout, payment, all these will be separate microservices. If payment gateway fails also, still users will be able to search and identify and adding the products to the cart. By the time this microservices issue can be resolved, so it will not impact the entire software. So that is the core safety for microservices architecture. As I said, I have more details about the different type of caching and optimization techniques. So the caching is a technique used to store infrequently accessed data in high-speed storage medium to reduce the time required to retrieve and thereby improving the overall performance. There are different type of caching. The caching like in-memory caching, where we will store in RAM, database caching, content delivery network, which is the emerging technology to have the content across the servers across the world, and browser caching with each other, their own use cases and benefits. If we come to in-memory caching, stores data in applications RAM, which provides extremely fast access times compared to disk-based storage. This particularly using for frequently accessed data such as user sessions or application configurations. Database caching is the next one. Database caching involves storing frequently accessed data from a database in a separate cache, which will reduce the load on the database and improve its response time. Techniques like query caching, object caching can be employed in it. CDN caching, as I said, one of the emerging technology, which is used in most of the highly scalable applications which we have seen now in the second slide. Content delivery networks cache static contents such as images, CSS, JavaScript files on servers distributed across the world, reducing the distance between the user and the content and improving the page load times. In this CDN caching techniques itself, we have one more concept, which is also an emerging concept for scalability called edge servers. If you are incorporating CDN caching with edge servers, then the performance and scalability is unimaginable, as we see in WhatsApp, Facebook, architecture, Netflix, etc. I will come to that one. It will be a future stuff. Next one comes to browser caching. Browser caching allows all the web browsers to store static contents like images, style sheets, which is locally, and reducing the need to re-download them from the server on subsequent visits, thereby improving page load times. Anytime user visits a page, the home page details, all the static element in the home page will be browser cached, so that whenever user log into the page, no need of utilizing any resources from the browser till the server. So implementing all this caching strategy will contribute a lot to performance optimization. I will tell little about asynchronous processing. Synchronous processing, as I said, it will allow the system to handle the task without waiting for the previous task to be completed, which enable the parallel execution and improving efficiency. It will not block the execution thread. The result of asynchronous processing is highly improved responsiveness, increased throughput, and reduced resource utilization because no one is idle, and enhanced scalability. If we explain about load balancing and clustering, that will distribute the incoming network traffic across multiple servers to work as a single entity, providing redundancy and fault tolerance. If we are implementing load balancing and clustering, we can improve the throughput by 90%, we can improve the response time by 85%, can improve the availability by 95%, and scalability by 92%. Let us see some case studies, which is not limited, but I have taken some best case studies out of the highest performing software as a scalable software. Optimizing Netflix music streaming service. So Netflix is using microservices in AWS cloud infrastructure with its own open content delivery network to deliver the content across the world efficiently. If we are coming to Google Maps, its accuracy and performance is adorable. They are using the graph algorithms to calculate the shortest distance. If you are checking the Amazon's e-commerce checkout process, they are using microservices architecture with AWS cloud infrastructure for scaling and Docker for containerization and deployment, and service mesh technologies to manage the interaction between microservices securely and efficiently. And another strategy is multi-cloud strategy, which is getting implemented in Walmart, which is saving millions of IT costs. Walmart built its own cloud platform first and tied it to public cloud providers, creating multi-cloud architecture that saves millions in costs. Optimizing multimedia content delivery by Facebook. Facebook uses the edge servers, which I said in the previous slide, and content delivery network to optimize the delivery of multimedia content. So Facebook is keeping the servers on the network edge, which is more close to user. And again, this caching technique of content delivery network. So altogether, anytime, every time, the frequent multimedia load is able to handle by Facebook. These are some wonderful case studies. Some best practices we need to do always is to see any bottlenecks are available in the system by analyzing the application to pinpoint areas with high resource consumption or slow response times. So optimizing database queries, ensure the database queries are efficient, appropriate indexing, and leverage caching mechanisms. And leverage asynchronous processing for always to do the background processes to improve overall system responsiveness. Always improves the caching strategies, which is to use frequently accessed data for computational to reduce the load on system and improve response time. Optimize the resource utilizations by ensuring the use of system resources such as CPU, memory, network bandwidth to support their concurrency and scalability. As I said, horizontal scaling is recommended over vertical scaling. For that, we can add more and more instances to the applications or service to handle increased load. So the moment concurrency users started using the applications, the moment it gets loads, horizontal scaling will spin up the machines frequently in the backend. The moment the user load is reducing, the scaling, as per the configuration, the scaling will spin down the systems and reduce the utilization, will save the resource utilization. The leveraging distributed system design, adopt an architecture pattern like microservices, message queues, load balancing to improve scalability and resilience. So these are the future directions. Now, most of the software systems are getting migrated to cloud system. That is still ongoing. We have one data centers, softwares are still in legacy technologies. So things will change. Quantum computing is one of the area which is emerging one, which we can use for leveraging and revolutionizing software performance through different algorithms and parallel processing. Serverless computing, till now we were focusing on server computing. Serverless computing will come, optimizing software scaling and elasticity through different architectures, and it will function as a service. Artificial intelligence and generative AI, which will already taken the market now, industry market now. It will be the one of the best option for optimizing software performance and scaling in coming days. Researchers are still going on that, integrating AI-driven performance analysis and predictive modeling. Predictive modeling is the highlight to automate software optimization, which will help for resource utilization also. Edge computers, which will stay with keep edge servers in the edge side of the networking to avoid latency, is getting adopted by the top performing softwares and which can be adopted by all our future endeavors. It will enhance the software performance and responsiveness by offloading computer intensive tasks to its devices and both IoT networks. In upcoming world with smart devices and IoT networks, we will have to adopt edge computing. Programming languages advancements are on the way, exploring new programming languages and paradigms that enable more efficient and optimized software development practices. Hardware software for design will be an coming area which will foster and tighten the integration between hardware and software to create custom high performance computing platforms. Hope you enjoyed my speech. Happy performance optimization and global scaling in your future products.